Hello everybody. testing, check, mic, video, we got them all. Yep, testing. Alright then. Hi everybody, it's Saturday afternoon, 5 o'clock, 5:30 actually. So is our regular live stream event. Today we're gonna jump in straight away. We're gonna talk about, as the board says, voltage regulators. This one, voltage regulator, how this one impact our life and where we can find them all over this place. Yeah, voltage regulators. Alright then. So basically you can find these voltage regulators all over your life. You know, charging your phone, most likely with this kind of device. So inside this one is a voltage regulator as well, which is gonna regulate the voltage to charging your phone. Alright, so first thing, when we speak about voltage regulators, we have to have in mind two things. If it's gonna be on the low side or on the high side. What I mean to this one is, if you want to charge your phone, right, you have to know the power source. Is gonna be a 9 volt, no, actually this is not a good example. It's gonna be a 1.5 or a 9 volt battery. This is on the high side and this is on the low side. Basically what that means, this is the phone, yeah, this one requires 5 volts to be charged. So we have to know from which power supply we're gonna charge it from. If we're gonna charge it from lower side, low means this power supply is less than our phone, or is greater or high, as I mentioned before. All right, we're gonna treat them each one individually. All right, so we have our phone. Yeah, we're gonna start from the low side, and in the middle it's 5 volts. Yeah. We're gonna start from 1.5. In order to be able to charge your phone with one AA battery like this one, or even AAA, you're gonna need something that's called a boost voltage regulator, like this one. This is a very special one. This one can step up the voltage from 0.9 all the way till 5. It's gonna step it up to 5 as well. As close as the 5 value is, as this, the less the stress on the battery or whatever you're gonna power it from is gonna be. All right, so it's possible. You saw that video clips, you know, charging your phone with batteries, hacks, wherever, Russian hacker, American hacker, whatever. But on the low side, with this battery and this special charger, is very tricky. What I mean through that one is, because is gonna be the stress, the greater stress on the battery to step up the voltage. Basically for this one, to be able to step it up, as I show you here, is gonna have an LED indicator, which is not on now because the voltage is too low. So in order to this one, to step it up all the way to 5, it's gonna draw some amp. It's gonna draw amps twice. One to step up the voltage, and then to regulate the current according to your load. But that's another topic. So, but this is the most inefficient way, because it draws a lot of amps and output is very difficult to maneuver. All right, another example, you know, this one, power banks. Yeah, this is a cheapy one. This one, inside of this, there is a lithium-ion cell, 18650, which, again, a similar module to this one is inside this thing, which is gonna step up the voltage from 3.54 all the way to 5. But even that one is high. Imagine this way, to be able to charge your phone with one of these, which with this one is impossible. Charge it all the way. From this one to charge your phone with 500 milliamps is gonna draw from this battery 1 amp. That's why when you buy power banks and stuff, be very careful. This one, it says, is rated at 1200 milliamps many times. So in order to this one to be 1200, this is just the rating of the battery inside. The battery could be 1200, but in order to this one to deliver 1200 is gonna be 2400, and so on. As greater the value, as bigger the battery should be inside. So for this one, because this one has inside 1200 milliamps battery, it's not going to be able to provide all that power. In order to this one to provide 1200, it's going to have at least 2400 milliamps. Yeah, so that's why when you buy a power bank, be very careful. Look at the specs, at the specification, and what you saw there, that's the battery inside. So if you can find this one cheap all over the place, and they are rated with 1200, buy them and use them for the project, but never expect this one to able to deliver. All right, so we are still on the low side. We have soda 1.5. We saw the 3.5, most common. And now with 5 volts, we can charge our 5 volts thing, but that's in a perfect scenario. So it's very likely that you're gonna have a 5 volts battery or a 5 volts power supply that's gonna deliver exactly. All right, now we're gonna go on the high side. We're gonna start from this 9 volt battery. Yeah, with this 9 volt battery, you saw the many clips, they are able to charge your phone. It's a low capacity battery, but with a proper one, maybe recharged. The same is applied when you have your car, yeah, the car phone charger. Everybody knows what this one is. This is a car USB charger, classic, or it can look like this, the same stuff. This is on the high side, on 12 volts actually, because your car is designed to work on 12 or more volts, yeah. And this one, we can see the specs here: input 1224, output 5, maximum 1000 milliamps. This one doesn't say nothing, probably from China, cheapy cheap. All right, so this one is more reliable to charge your device with the high side, because the voltage is greater than your thing. It's gonna be less stress to the battery, because the battery already has a different potential, bigger than this stuff. Yeah, but this one doesn't mean that it's not gonna draw power. Basically, all the electronics in our lives are designed to draw, to consume power. Yeah, so even if it's gonna be charged from the low side or from the high side, it's still gonna draw some current besides the current actually needed for the battery to be charged, and so on. Yeah, all right, we're gonna go more further. This one, everybody knows what this one is. This is a wall charge adapter. This one says here input 240 volts AC, output 5 volts DC, 1.2 amps. Yeah, this is a very crappy charger, bought from Poundland, £1 exactly. Imagine the value for the money. So this one is a charger, nonetheless. It's not safe, but it's doable. We can do lots of stuff with this one as well. Yeah, so in order to know how to charge our phone, our batteries, and so on, all these voltage regulators are all over our lives, and they are disguised in this kind of chargers, or in this charger, or in this one, and so on. All this stuff are voltage regulators that helps you regulate the voltage to be stable and not be greater or less or to your thing. All right then. As you can saw on my previous videos, I started now to play with some thermoelectric generators, which I have encountered in the same problem as here with the voltage regulator. Yeah, Basically, if you're gonna look in the description after this live stream is gonna end, you will find some links to my previous videos that I'm gonna show you the thermoelectric generator model 1 and model 2 actually working, and now we are working on model 3 as well. We doubled the capacity and the stuff, so we will see if we're gonna be able to charge our phone. So we have to deliver at least 5 volts and let's say 500 milliamps, and on top of that we have to run 2 fans, which they're gonna draw like 200 milliamps, and an LED bulb or light or something like that, which is gonna draw as well 100 milliamps to be able to light a room close to what we need day to day. So in order to achieve that, we're gonna have like 5, 7, 800 milliamps. Yeah, till now we have managed to deliver 5 and 400, but you never know. If you know some Peltier module or TEG module, let me know in the comments below as well. I'm gonna test a couple of them, but I don't have the resources, the time and the power to test all the cells there. If you're gonna do a search on YouTube, you're gonna find a clip. It's called DIY Thermoelectric Generator, whatever it is, with a young lad who's speaking something about brighter future or whatever. But it shows a thermoelectric Peltier module, which is able to charge a phone straight away just from a boost converter, so basically a step down converter, and is providing a fan as well. As I saw the video, seems genuine, but the comments are not that good. It says that he has used the Peltier module is 12726. Is a 300 watts cooling module, whatever. I looked it up. When you look at the Peltier module, you divide it into 2 sections. This one is the thermocouples, which are 127 modules, and 26 is the amps, 26 amps. So in order, it's gonna be like close to 300 or so. But we don't know if that one is somebody tested it, somebody are using it and able to generate power with it. We don't know for sure, but if somebody knows, let me know in the comments below or on other video or on the comments what is gonna be, and if it's worth it to give it a go, and we're gonna put it to the bench to see whatever is gonna output. But in the meanwhile, we're gonna use our stuff here. I'm gonna show you straight away. The thermoelectric generator is working for a while now, and I'm trying to charge the lithium-ion cell, but till now we don't have that success. We're just able to light some LEDs around the fans to cool the Peltier module, and some other small devices like a small radio, FM radio, and so on. Yeah, so we're gonna go to the bench, and I'm gonna expect from you guys, to let me in the comments below which one is the best Peltier module, or if the TEG is worth having a go. We never know. I tried, I think, once a TEG, but could be a fake one, so the tests are not conclusive. Alrighty then. Now let's go to the bench and show you the actual thermoelectric generator in function. Alright, here you go. Here you go, friends. The thermoelectric generator is a mess here on my desk, but I'm gonna show you. You see, this is the thermoelectric generator, 2 modules, 2 fans running, 2 candles as well, providing the power, and a lot of messy wires and so on. And we are trying to charge a lithium-ion cell, but for the moment I'm gonna disconnect it. Yeah, it's still working or not. Yeah, so we are testing it to see whatever is gonna be. Who knows? Alright then, we are back on the board here with our thing. We're gonna go back to the topic, to the voltage regulator thing, and I'm gonna show you that it's possible to use this one to run a fan or even light an LED or so on. Let me try and find my LED. Jesus, that's live, folks. This is live, so shit can happen. Alright then. Okie dokie. Alright then. Okay, so we have this one. This one is a 5, so it's close to our phone. If we're gonna connect plus and minus, it's very thin, bastard. See, it's not gonna work. It's not gonna light. But if we're gonna connect this stuff, which is a step-up voltage regulator, we have here an USB output. We're gonna connect it. So minus to this connection here. Tick, tick, tick. And plus. Come on, it's so thin wires, man. It's very finny. Alright, so we have the LED. And we're gonna connect with our tiny battery, as you can see here. Plus, there you go. You saw? So this step-up voltage regulator is working as it should. Yeah, because it's designed so there's no question there. But the process to stepping up all this voltage and all the way there to be able to light this LED is gonna cost us some amps. In particular, this setup is drawing next to 400 milliamps. So this is the best joule thief, if you know the concept, the joule thief or ladrón de Julios or whatever it's called this day. This one is a commercially available joule thief or voltage regulator, step up, boost converter, whatever you want to call it. Yeah, so this one will run from 0.9 all the way to 5. But as small as the input, if it's gonna be like 0.9, it's gonna draw like next to 600 milliamps. But if it's gonna be greater than that, we're saved, so it's gonna draw less. So as bigger is the input, as close to the output, the potential difference is less, so the current draw is less than the thing, you know. Think it of this way. These power banks provide and requires 5 volts to be able to charge your lithium-ion cell. Let's say this is your lithium-ion cell. It's gonna start from 3.5. It's gonna climb the voltage all the way to 4, 4.2, 4.1 or so. And when it's gonna reach that voltage, it's gonna stop. Why? Because it has reached the equilibrium. So 3, let's say 4 from this side with 4 from this, that's it. No current is gonna pass. So this one is fully charged. If we're gonna be able to achieve that in our circuits, we're gonna be masters. But in the meanwhile, I have a question for you guys. Have you heard about negative resistance? So minus, I think it's working today. Minus ohm, so negative resistance. I have heard about the concept. I never tried, but I think I will, because with these thermoelectric generators, we're gonna need some resistance, you know, to draw back the resistance and go up amps and so on. But concept and more detail and reliable and worthing folks. Comments below and let me know what is gonna be the next topic about. From now on, I'm gonna try to make this one a regular thing, a steady. Every Saturday, 5:30, we're gonna do the live stream, and in the middle the regular videos, Monday and Thursday, and maybe one more. We will see depending on the schedule and whatever we have in mind. All right, so in the meanwhile, don't be a stranger, thumbs up, put the comments below. I'm gonna read all your comments, I always do, and as long as you are polite and genuine and stuff, I'm gonna try to help